The first named quadrilateral that we are going to be looking at is the parallelogram. And the parallelogram is a pretty straightforward idea. Something there it is. And it is basically is going to be a quadrilateral formed by two pairs of parallel lines. So I can, again, we always want to make these determinations not by what they look like, but rather what you know. So what could you be given to show that this is a parallelogram? Well, I could come right out and just say ABCD is a parallelogram. Or you could have marks like this. Remember, you got two parallel marks on one and one on the other, because if they were the same parallel mark on all of them, it would mean they're all parallel to each other, which is clearly not the case. Or you could be given a statement like AB is parallel to DC and AD is parallel to BC. Either way, then you can consider that quadrilateral a parallelogram. Consecutive sides are any two sides that meet at a vertex. So for instance, if we were to look at this particular parallelogram, which now we can call it that, AB and BC are consecutive sides because they share the common vertex of B. Same with CB and CD and so on and so forth. You don't have to keep going and naming all of them, but if two sides have a common vertex, then they are consecutive. Consecutive, kind of think in terms of consecutive as the next one you come to. Likewise, we have consecutive angles or vertices that are connected by a side. So angle A and angle B are consecutive. Angle B and angle C are consecutive, so on and so forth. As you work your way around, if you start at a particular vertex and work clockwise or counterclockwise, as you go around the figure, the next one you come to, whether that be a side, whether you're looking at the sides or looking at the vertices, those are consecutive. Now, when you name this parallelogram, this one would be parallelogram A, B, C, D, or ADCB, or whatever. You have to be able to name it either clockwise or counterclockwise. Don't name this one ADACB, which I think I talked about in the previous lecture, but always name it in order, connected by the sides. When we're talking about, we can also have, and I'll put the marks back on this for parallelogram, so we can know that this is a parallelogram. Easier to draw them in than try to do them with the computer. Opposite sides are any sides that do not share a vertex. So if we're looking at AD and BC, all the letters are used if you're naming a pair of opposite sides. No letters in common. If they have letters in common, they're not opposite because they are consecutive. And opposite angles, two angles or vertices not connected by a side. So if you can't get from one vertex to another without passing another one first, another vertex first, they're going to be opposite. So for example, if I start at angle A rather, and I want to get to angle C, I can't get to angle C without first getting to going through D or B, so I know that A and C are opposite. There's no side that connects those two. There is, however, a diagonal. So again, we had that from the previous lecture. We have, if it's connected by a diagonal, I'll go back a little, I'm kind of talking about the previous slide. Opposite angles are connected by diagonals. Consecutive angles are connected by sides. So it's what connects them is what kind of determines what type they are. Right? Now those terms, consecutive and opposite. We're going to use those in other things as well, but for our immediate purposes, we just want to have them for our definitions. And when we start looking at some of these properties of parallelograms, it's nice to have those to reference as we move forward with some of our properties here. So we're looking at our parallelogram here, and just from here on out, I'm not going to put these in, I'm just going to call them parallelograms. So all of these AB, I'm using the same quadrilateral. So if we are looking at a quadrilateral, that is a parallelogram. So if we know a quadrilateral is a parallelogram, as we do here, then we can assume that its opposite sides are congruent. Opposite sides are congruent. So AD is going to be congruent to BC, and so on and so forth. AB is going to be congruent to DC. Some of us were kind of getting to that on one of the questions on the summative, one of the level 4 questions on the summative, when we were, how did we know that one side was parallel to another? And I was really hoping that you would get to that one by looking at the triangles being congruent, looking at the corresponding parts and all that. But some people were trying to reference this idea that, well, if for A and B to be congruent, for AB to be parallel rather to DC, AD would have to be the same length as BC. If not, then we're going to be talking about, we might be talking about something that would cause the other lines to intersect at some point. So if we know a quadrilateral is a parallelogram, then we can assume that the opposite sides are congruent. Where else can we extend that line of thinking? Again, this is a parallelogram. I'm telling you that. I just didn't want to take the time to put the marks on it. I don't want the lecture longer than it needs to be. And so we're looking at if a quadrilateral is a parallelogram, then its opposite angles are. Well, so if we were to look at angle A here and compare that to the measure of angle C, if you're saying at home that it's congruent, you're right. It's congruent. And likewise for D and B. Now, a lot of these ideas, when we're talking about angles and we're talking about, with parallelograms, which means they're made up of parallel sides, we've kind of already covered that, haven't we? When we talked about parallel lines and transversals and the angles that they form, it's all these properties stem from those properties. And we're going to look a little bit at this same figure a little bit differently for the next one, but we'll be able to kind of maybe see this parallelogram as a figure created by parallel lines and transversals better with the image in the next slide. Okay? So we can then we can say that angle A is congruent to angle C, and angle B is congruent to angle D. Now, this is where I was talking about here. I took that same figure and I just put these auxiliary lines in so you could kind of see that what we have here are parallel lines, and AD is a transversal, right? And what that allows us to say is, okay, let's just take angle D, right? And because these lines, we know that line BC is parallel to AD, we can turn around and say that, well, if I know the measure of angle D, I know the measure of angle C, because these are corresponding angles formed by parallel lines. We also know that AB is parallel to DC, which then allows us to say that, well, this angle C here is congruent to this one because these are alternate interior angles. And as a result, if we stay on the inside of the figure, we know that D and B are congruent. So that's where that previous idea comes from. Well, we then look at A and B, and we know that they're congruent as well. Well, we've already kind of got the next one down. The previous idea talked about the relationship between opposite angles in parallelograms. Well, if a quadrilateral is known to be a parallelogram, then it's consecutive angles. We're talking about A and D, A and B and C and so forth are supplementary. Again, we've one way to name same side interior angles, which angle D and angle A are, if we're just using the names from the quadrilateral from the parallelogram, these are same side interior, or like some books call them, I think our book calls them consecutive interior angles, and they're supplementary. We already kind of know that property. And again, that's just all of these things here go toward establishing a relationship between two things that allow us to say this is going to be equal to that, or this plus this is going to add up to something else, which is most of what we do in this class. Why we learn the properties of these things. Okay, go away. And that's why we learn it, to set up those relationships so we can solve. One more idea in parallelogram properties here. And what we've got here are both of the diagonals in the parallelograms. And we know that AD, it's a parallelogram, is parallel to BC. So I know that this one here and this one here, are congruent because these are alternate interior angles. And since I also know that AB is parallel to DC, I can make the same statement about this angle here and this angle here. And if I name this point here, just to give it we'll give it point E. Right? We can say that triangle AED is going to be congruent, AED, to triangle CEB. And that's because of angle, side, angle. We know that the opposite sides are congruent, so these triangles are congruent because of angle, side, angle. Right, from our previous world. And because of CP, CT, C, I know that AE is going to be congruent to CE. Which means this diagonal here, this diagonal DB, did something pretty specific to diagonal AC. If a quadrilateral is a parallelogram, then its diagonals bisect each other. It means it cuts each other in half, right? So I'll just finish this thought over here before I, so AE is congruent to EC. And that's because of CP, CT, C. Corresponding parts of congruent triangles are congruent. Now, I could go through that whole process again for these other sides DE and EB. I don't think we really need to because we've already kind of established that. But if you know a quadrilateral is a parallelogram, then its diagonals bisect each other. Popular mistake is to say that if it's a parallelogram that the diagonals are congruent. They can be, but don't have to be. but they definitely bisect each other. They definitely cut each other in half. So that is what those are the parallelogram properties. We're going to get lots of practice whenever we're back together again, which who knows when that will be. We'll get plenty of practice in class applying these and solving for unknowns once we've established that we have a parallelogram. Please let me know if you have any questions. I hope this helped.